Hey math kids, today we're going to talk about the cosine rule. We are in chapter 8, section C in your book, and if you look at the beginning of this section, there's a blue box and it writes the cosine rule in a number of different ways, and personally, I think this is overkill with how much they write it, instead of just explaining the thinking behind it. Since they provide it, I guess I will provide it as well. So this is related to a diagram where we call this B, we call this C, we call this A, which is the name of those angles. And then the naming convention that we talked about in a previous video, the opposite sides are just lowercase letters corresponding to that. So C and C, B and B, A and A, so on. Now, essentially what this is just the Pythagorean theorem for non-right triangles. So if you notice, this piece of it is just the Pythagorean theorem. Another thing you can go through, I'm not going to do it on this video, but you can actually use this on a right triangle and you will see that this will just go to 0 and go away. So it really is, you've been using a piece of the cosine rule with when you were doing the Pythagorean theorem all these years. Okay, so what it is, all of these lowercase letters are referring to sides, and then we have one angle. So the important thing to note, don't get so focused on which letters or where or whatever. The way that I think about it, we need to make sure that our angle that we care about, so maybe we're solving for an angle or maybe we know an angle and we're using it with this formula, the important thing is that that angle is opposite the side that we're calling, that we put by itself on the outside. So notice how this is A, this is A, this is B, this is B, this is C, this is C. So this is an angle, this is a side, angle, side, angle, side, so on. So that's the only thing you really need to line up, because A and B don't matter. Because right here we're adding, and if we flip addition, it doesn't change it. Right here we're multiplying. If we flip multiplying, it doesn't matter. Okay. So we're going to move on to the first example, which is example 3. And it says find correct to 2 decimal places the length of BC. So we want to find BC. We're given a diagram that looks like this. We have 42 degrees. This is A, C, B. Then we have 11 centimeters and 13 centimeters. Okay. So we know we're using cosine rule. And we want to find BC, so I'm just going to put an X right here to mark where we want to find. And if you remember, before I scrolled down, I said that the two that are opposite need to be opposite in the equation. So we take that side, x squared, and then we need to make sure when we do the cosine over here, it's 42. So because 42 degrees and x are opposite, they need to be like this in the formula. Now, the other part of the formula doesn't matter. I can do 11 or 13 first, doesn't matter. So I'll say 11 squared plus 13 squared minus 2 times 11 times 13, and then I finished out that formula. Okay? Now, we need to solve for x, so really what we could do is just square root both sides, plug all of that into a calculator, and call it good. I'm going to go through with a calculator. So let's see, I'll pull open this calculator, and I'm going to do it kind of step by step with you, because I think it's a little bit more useful that way. So when we're doing this, let's see, I'm going to zoom out a little bit so we can see it and work on it with the calculator. Okay, so we're gonna square first right here these two things, as well as multiply these numbers out. So that's going to be 121 squared plus 169 squared, 13 squared. And then we're going to get negative 2 times 11 times 3. So negative 2 times 11 times 13. I said 3, I meant 13. Okay, so negative 286. Is that what it was? Yeah, 286. Then we still have our cosine, 42. And that's still equal to x squared. Alright, now I'm going to just combine these two. So let's see, we're going to get 6, 7, 8, 9. So 290 minus 286 cosine 42 x squared is equal to that. Now, the most common mistake kids will make is they will try to just combine this because it's so tempting, because the numbers are generally pretty close. And so we just say 290 minus 286 and we get a 4. And so that seems like we're going on the right track. Problem is we're forgetting about Pemdas. So on Pemdas, we need to take care of the multiplication that's going on here before we take care of addition or subtraction. Okay, so don't fall for that trap. So the next thing we need to do is do negative 286 times cosine 42. Now, make sure you check to see that your calculator's in degrees. You just hit mode and go down to degrees and then hit enter. And then we're going to say negative 286 times cosine 42. And then while I'm at it, I'm just going to add the 290 so we can be done. We could have put this whole line in actually all at once. I probably should have done it that way. But if you put that in, it's 77.46. And then we need to just finish the algebra on that, and we're going to square root both sides. So something we can do, we can actually just raise our answer to the 0.5. Because remember, if we have an exponent of 1/2, that's the same as square rooting something. And so we have, how many decimals did it say? To 2 decimal places. And so we're going to say 8.80. So BC is about 8.80, what is it, centimeters? Okay, centimeters. Okay, so that's our answer on example 3. Now on example 4, they give us